holidays, to be honest.
Yeah,
The time doesn't exist anymore, so I don't really know.
Yeah, exactly.
There
is no holidays.
Yeah, we don't get a holiday anyway. It's just no more content.
Yeah, I've got to do spatial when I've literally the second I finish this talk, I'm going to start trying to do spatial final assessment.
Yeah.
Get it done and dusted.
Yeah, I have a. Did you do aquatic verts or did you do mammals?
Yeah, I did aquatic verts.
Yeah, I've got to do the grant proposal for Monday, and I haven't started it yet.
Oh, that took me under a day.
Okay,
so
that's fine.
It'll be fine. Yeah. I was doing fish and I was doing great whites though, so it was quite easy to talk about, you know.
Yeah, well, I'm gonna do sharks, but not great whites because they're basic.
Oh, shut up, Seb. Okay. There was a lot of literature written about it in like 2019 to 2020, so it was like, oh, look how performance caught you. So,
yeah, you can use trackers on sharks to track tornadoes.
Are you going to do that?
Yeah.
Sure. Are they water tornadoes or are they land?
No, they're ones on land. What do you think they made Sharknado about?
Yeah, no, but Sharknado. Are you saying? Hang on, is one of your sources going to be the film Sharknado?
Yeah.
It's not.
Sharknado scientifically accurate.
Yeah, it is.
Is that what you're saying?
That bit where the guy jumps through a shark with a chainsaw and then comes out the other end of the shark.
Yeah.
That's scientifically accurate.
Perfectly feasible. Love it. That's your new quote. Put that on your bio.
I think you want to reference something really silly in one of my essays one day.
You should just go for it.
I think I referenced Jaws. I don't know if that's silly though.
I'm gonna got to get Sharknado in there somewhere.
You could just put it at the end, like the impact.
You know, that actually did give me an idea. But what if you can do weather tracking with fish? Because then I can definitely drop in Sharknado somewhere. Like I just came up with that off the top of my head, but that might actually be quite fun.
Yeah, I made sure the stuff I was doing actually was real stuff, and I talked to the guy about it. Richard Shirley's a big source of information, so I'd recommend using him. Right, it's past 7. I'm going to start with or without George.
Do you just record us talking about Sharknado for like a couple of minutes?
Yeah.
All right, whatever.
Okie dokie. Hang on. Right, you can see. You can't see me, can you? That's good. I don't want you to see me. You can have your cameras on if you want, guys. So I'm not going to stop you. You're all muted now, aren't you? You're not going to talk to me. Okie dokie. Okie dokie, picking up Okie. Good morning, job seekers. We're going to be kicking off the talk. Okay, so it's this talk is about the Permian period of history. Very exciting time, the time before the start of the dinosaurs, but it was also the end of an era, the end of the era where the world was dominated by invertebrates, the good old days, as I like to call it, and the rise of the reptiles. It's when it began. After it, so we're gonna get right into it. First of all, we're gonna have a little overview of what the Permian was, what it was all about. So it lasted for 47 million years. It was from the 290 million years ago to the 250 million years ago, if you want to do it in terms of that. It was, so it's placed nicely in between the Carboniferous and the Triassic, the Carboniferous being another exciting time period that I could do a talk on if you would like me to, and the Triassic being the first, where the dinosaurs really started to take over the world. It's named after a place called Perm in Russia, where it got its name from, and that was because the first rocks from the Permian period were found there, so they named it after where the rocks were from. I'm pretty sure they do that with a lot of the rocks. That's why the Devonian's called the Devonian, because the rocks were first found in Devon. The main things that Permian is important for in terms of evolutionary history are the diversification of egg-laying, hard-shelled egg-laying creatures, or amniotes. So like the first lizards, they first appeared in the Carboniferous, and then they began to diversify a lot more in the Permian, and they turned into the what we now know as early mammals, lepidosaurs, and archosaurs. And archosaurs are what dinosaurs would become. The pterosaurs, I believe, are just so if we look at the map on the right there, you will notice that this is the time period where Earth was Pangea. Everyone loves Pangea. They talk about it all the time. They're always going on, oh, I loved it. I loved back in the day when the Earth was Pangea. This is the geological time period when Earth was Pangea for the entire time. It was also, I mean, it was Pangea before and Pangea for a tiny bit after in the Triassic before it began to split up. It split up by the end of the Paleozoic, which is when the Mesozoic, apologies, which is when the dinosaurs were. But this is the Permian is when Pangea was at its peak of Pangeanus. And the main reason people talk about it in modern contexts is they compare what happened at the end of the Permian, which is the greatest mass extinction man has ever seen, the Earth has ever seen, and they're comparing it to the modern day mass extinction that we're suffering. And we'll look at that a little bit later on in the presentation. What we're going to be covering today is, first of all, we're going to be looking at the diversity of terrestrial life, and there's a little joke there, a little meme there about a couple of the species you may find in the Permian. We're going to then be looking at the return to the water of some of the animals, and we'll be looking at the other marine life that would have been around in the Permian. And then we will look at the we'll look at the Permian Triassic mass extinction, or the Great Dying, in the section called "The End of All Things," which I'm fairly sure is a sort of Lord of the Rings-ish sort of reference. Quite proud of that. And then we're going to do a little bit of experimental theoretical biology as we look at what may have happened if the Permian mass extinction had never happened and the animals of the Permian had continued to develop, and up until the dinosaurs mass extinction of 65 million years ago, which we will still be considering to have happened, that big old meteorite. Right, so let's kick things off with life on land, and let's look at this section is going to be covering the diversity of life on land from the start until the end of the Permian. We will be looking at what it was like coming out of the Carboniferous period, and what it will be like towards the end, towards the late Permian, and that will sort of what we'll be focusing on a bit more, I think, the late Permian. But we'll look at how life on land changed. You may notice some parallels from this sort of this radiation and modern life, and we'll get why that is later. And intriguingly, we'll have a little look. Okay, so we need the context of why the animals looked like they did and acted like they did, and the ecology of them. And so we need to have a little bit of background. We need to have a little look at the background of where they came from. So the period before the Permian, the Carboniferous, that is where all of these creatures originally evolved. And the Carboniferous was a very different environment to the Permian. The Carboniferous was extremely hot. The world was very hot. There was an extremely oxygen-rich environment, which led to lots of wildfires, which we'll get into if we ever do a Carboniferous talk. And it was dominated. It was very wet. It was dominated by swamps and forests. Huge swamps covered all of the landmass. Obviously, there's still the huge oceans, because Pangea is just one continent, and there's lots of ocean, one giant ocean around it. But on land, there were huge forests with huge amphibians that lived in the swamps. They were the main sort of large predators, and they filled all of the land niches. And giant insects filled in those that weren't those that the amphibians didn't fill in. The insects could grow to such large sizes because of the oxygen content in the atmosphere. You'd seen things like the 2-meter long centipede / millipede, I believe they think it's a millipede now, Arthropleura, and Meganeura, which is a giant dragonfly type, which we will get to a little bit later on, interestingly enough. At the end of the Carboniferous, there was its own extinction event called the Carboniferous rainforest collapse. And this led to the formation of these huge early Permian, and to be honest, all of the Permian deserts. And so during the Carboniferous, there had been a slight change in some of the amphibians, is that they'd stopped laying soft-shelled eggs, and they'd started laying hard-shelled eggs. And so the soft-shelled eggs and amphibians, they couldn't really hack it in the huge deserts. So the hard-shelled eggs, amniotes, they managed to thrive in this new environment that had been created, and so they spread out and filled in all of the niches on the land, and they diversified and created all these new cool life forms. So yeah, this section is going to pretty much just cover the amniotes, but first we're going to have a little look at the non-amniotes. So we'll cover the amphibians that did survive, and the insects also that survived and made their way into the newly blossoming Permian. So amphibian wise, there were some pretty cool amphibians still. I'm not going to lie to you. Pre-dinosaur amphibians are incredibly interesting. They don't resemble stuff we have today in terms of our frogs, newts, and toads, or salamanders. Well, they're fairly salamander-similar. They're salamander-ish. They fill in very different niches back then. There's a much more interesting creatures. So amphibian-wise, we have the temnospondyls, which were usually extremely large. They sort of looked like giant salamanders, but usually even crocodiles. So they weren't crocodiles at this point in time, because the crocodiles are amniotic. So crocodiles needed to leave and develop, and before coming back to the water, which they did in the Triassic. And we'll see that a little bit. Well, we won't see that if we do a Triassic one. We'll look at the rise of crocodiles, and lepospondyls, which are an incredibly diverse group of amphibians. I haven't put a closed brackets there. If you could just ignore that, and we'll look at their variation. This slide particularly is looking at insects. So insects had obviously had a really great time of it in the Carboniferous. And so there's a lot less to talk about insect-wise in the Permian, but there's still some cool things that happen. So if we look at the picture on the right there, you'll see a Meganeura. Meganeura is this giant dragonfly type thing I described beforehand that it survived the Carboniferous, the rainforest collapse at the end of the Carboniferous, and survived into the early Permian. So there were still a few swamps that they could hack it in on the coastlines in the Permian, and so they were still around, and they were huge. Although I may add, the picture has based the reconstruction of the Meganeura on a dragonfly, and they weren't actually dragonflies. They were sort of primitive dragonflies. They may have looked more like, if you look at the picture in the top left there, the D there, they may have looked a little bit more like that. So the upper left picture there, that is detailing Archaeoptera. Now, Archaeoptera probably sounds like Archaeopteryx, the early bird, but now Archaeoptera are a group of insects. So these are sort of like the first flying insects that had evolved in the Carboniferous, and they really began to spread in the Permian. And their clear indicator of them being an Archaeoptera is the fact that they've sort of got this sort of like beak mouth, almost similar to like dragonfly larvae. Got that weird little beak that they've got that they can shoot out. These things all had that beaked mouth, and they resemble sort of caddisflies, alderflies, that sort of thing. But so yeah, these are sort of the roots of all modern flying invertebrates. They were these you'll hear a lot more of that today. These are the roots of right. Okay, so we're going to kick things off on the amphibian front by looking at the temnospondyls. Now, these are the giant giant amphibians. So we'll look at these amphibians first. So the temnospondyls had a great time of it in the Carboniferous, and they had a less great time of it in the very dry Permian. But there were still a good number of temnospondyls. So yeah, they were either these sort of small, it's almost frog-like. In fact, you can see my pointer in the top right there. They're almost small creatures like that Tambashia there in the top right. They were small amphibians, sort of reminiscent of like a chunky salamander frog cross, or they were these sort of large crocodilian almost looking amphibians like this Melosaurus in the top middle there, or in one particular case, one genus, Brownosuchus, which was a 9-meter long crocodilian amphibian monster, which probably ate freshwater fish, which at the time were largely lungfish and smaller amphibians. So temnospondyls filled in the crocodile niches that we have in modern ecosystems, but they also filled in the sort of smaller amphibian niches. We'll come back to look at Brownosuchus later in the theoretical section. But Brownosuchus is a very cool part of the Permian ecosystem. So lepospondylus, they look a lot weirder for amphibians, but so they sort of filled in other intriguing sort of weird little amphibian niches. However, so lepospondylus, they are being covered, but they were a lot more varied, and there were a lot more of them in the Carboniferous and periods beforehand. So they didn't really like the heat of the Permian, the heat in the deserts of the Permian. So yeah, they could look like anything. I've only got the snake and the Diplocaulus on here because they look very cool. But they could look like lizards. They could look like salamanders, or like Phlegethontia. They could look like snakes. They completely lost all limbs, and they were effectively amphibious snakes, which are really cool. I like the picture in the bottom right. I like it's got a sort of wry smile, like, haha, yeah, I'm not a snake. Yeah, I look like a snake, but I'm not a snake. Or Diplocaulus, which has an incredible head shape. They're not entirely sure why they had these. They presume they're sensory for muddy water, in the manner of like Amazon river dolphins have got good senses for the muddy water. So these would have had, in a similar way to hammerhead sharks, they'd have been able to sense around with their sensors on their lower skulls, Diplocaulus. But only one Diplocaulus survived until the late Permian, and they became extinct by the Permian Triassic mass extinction. Very sad. But now we're going to get on to the amniotes. So this is the beginning of the amniote. So first of all, we need to talk about sauropsids and synapsids before we get into the amniotes of the Permian. So at the end of the Carboniferous, there were two groups of amniotes. There were synapsids and there were sauropsids. So synapsids were effectively, I'm going to try and describe this in the way of what they are in the modern age, and then get back to the Permian. So synapsids in the modern age are pretty much just mammals. So all modern mammals are synapsids, whereas sauropsids are things like lizards and birds. But back then, synapsids and sauropsids were effectively just little lizards, but they had very slight differences in that synapsids had an opening in their skull roof behind the eye, which is pictured here. It's the hole behind the eye hole, and that's the difference between them and sauropsids. So this gave them an evolutionary advantage, presumably, and synapsids decided that the Permian was going to be theirs. They began to fill in all the niches, which is in sharp contrast, obviously, to the Mesozoic, where the dinosaurs, which are sauropsids, took command, and obviously the early Holocene as well, or not the Holocene, apologies. Just after the extinction of the dinosaurs, sauropsids had a pretty good time of it as well, but that was in terms of large predatory land birds, which is a little bit different. I can do a talk on that as well if you want me to. There's lots of interesting things about sauropsids and synapsids. So first, just before we get into all of the synapsid variation that we had in this time, there were obviously still some sauropsids that had a good time of it, because as we know, the dinosaurs were able to kick off. So sauropsids easily survived the Permian, but they were generally smaller, obviously with pariasaurs being exceptions. So these three groups here, pariasaurs, mesosaurs, and vigeltosaurs, are the most interesting ones. Vigeltosaurs there in the bottom left, that's a picture of one from the TV series Primeval. Phyllosaurus is that particular species. Pariasaurs inhabiting the large herbivore niche, and mesosaurs taking the leap and going back into the oceans. We'll get back to mesosaurs when we look at marine life, but for now we'll look at pariasaurs and then white-gallosaurs. The pariasaurs are not. They are. These are the exception to the rule of sauropsids not doing well in the Permian. Pariasaurs had a really great time of it. They filled in pretty much the large herbivore niche from the start to the end of the Permian. Their name means cheek lizards. This is because they have big cheeks, as you can see in these pictures of the scutosaurs here and here. They were large, scaly. Their key feature was there. So they have these sort of scutes and osteoderms. So the scutes are on their back. They've got like this sort of plating, and the osteoderms are hardenings under the skin. So they're very hard to break. They're effectively the precursor to shelled organisms, which is why for a long time they were thought to be an evolutionary precursor to testudines or turtles. But that was disproved when they found a link between a sauropsid and a turtle. So unfortunately, turtles are not related to these pariasaurs. It would be quite cool to have modern day turtles from these sort of large, chunky herbivores. The biggest species reached 10 foot long, and that was the named Bunostegos there. And the picture in the bottom left is of a Bunostegos. But the most common was the Scutosaurus, and Scutosaurus only emerged towards the late Permian, and they were sort of like the cow of the Permian. They were the generic large herbivore that would have provided food for the alpha predators of the time. But as you can see in the bottom right picture there, the smaller pariasaurs were the earlier ones, and they eventually evolved into the larger quadrupeds. So white-gallosaurs are an interesting one because they sort of evolved in the mid-Permian and into the late Permian, and they survived a little bit into the Triassic as well. So this is pretty much the first example of flight in vertebrates, vertebrates, not in invertebrates. So they had the reason that scientists think they could glide from the fossils is that they had airspace in their bones, and they had like all of the expected adaptations for climbing and gliding that modern flying lizards have. They also had obviously fossilized these really long membranes, this sort of bones which had seeming membranes behind them, which enabled gliding. And the other key feature of them, they've sort of crest on the back of their skull. You can see it best in the picture on the right, and that evidences the white-gallosaur from other flying lizards. Modern flying lizards don't have that. They were expected to be insectivorous, so they would have been feeding on the early flying insects. And the most notable species is Coelosaurus, which has got the most media attention, as it was featured in the TV series Primeval. And it also probably is the most well known. If we go back and we can see this skeleton here at the bottom of this slide here is the skeleton of the white-gallosaur that evidenced the wings. You can see the sort of wing structures there for gliding. So that's a pretty cool thing for the first flyers. But they didn't do too well with the mass extinction at the end of the period, and so we're going to get back to them in a big way in the theoretical section. But synapsids now. Synapsids are the predominant force in the Permian. They went through three sort of stages of evolving in the Permian, kicking things off with the pelycosaurs into the dinocephalids, before finally splitting off into gorgonopsids, decynodonts, and cynodonts, which I haven't included on there because I'm stupid and don't know how to make a presentation. So we're going to kick things off with the earliest ones, which is the pelycosaurs, which was the one you probably know most about. I've got them all pictured here, but we'll see which ones are which as we go along. That gentleman there is going to lose his left arm to that gorgonopsid. I have a bad feeling. I wouldn't be doing that if I was him. Let's just say that. So let's kick things off with the pelycosaurs. So you're coming out of the Carboniferous. You're the first synapsids. What are you going to do? How are you going to make yourself stand out from the crowd? That's right. You're going to grow a massive sail on your back. It's one way of going about things. So basically, the first Permian synapsids were these pelycosaurs, and a good few of them had these weird sails on their back. So they expect that these sails were for like heat control, so they could gain heat from the sun by sunning. Yeah, that's why they expect they have these crazy looking fins on their back. There's one of the species which is probably the most well known from the Permian, I would argue, is the Dimetrodon, which is seen in the bottom center there, attacking an Edaphosaurus. So the Edaphosaurs were or Edaphosaurs, the herbivorous version of the sail-backed creatures, sail-backed synapsids. They were the earliest known herbivorous amniotes. They had sort of mouth similar to modern day iguanas in terms of the fact that they were found to be herbivorous. They had tiny little heads, which is something you will notice in the herbivorous pelycosaurs, and they had these huge sails on their backs. So the sister taxa to them were the Sphecanodonts, or the Sphenacodonts. I always get that wrong, or wedge point tooths. So these are the carnivorous versions of the sail creatures, of the sail pelycosaurs. And they had these sort of crazy large mammalian-looking heads. Mammalian, they almost look dinosaur. They almost look like a T-Rex head. I find them very interesting, the way they've got this sort of crazy-looking head. And you'll see this head pattern sort of evolve and grow more as the time period goes on. So Dimetrodon is the most notable, but Sphenacodon is the sort of first Sphenacodon that began to evolve the fin and the head shape. So if you look at that's in the top right there, feeling on a Diplocaulus. And there were obviously in the early Permian, there were lots of attempts to find the right niches. So there were lots of very strange evolutions, such as the Cotyloryncus, which grew up to 5 meters in length. These were sort of the early Permian large herbivores, such as Cotyloryncus rameri there in the bottom left. And they had comedically small heads, and without the fin, it makes them look even more stupid. It died out quite quickly, so I feel like there's a reason why nothing else has got the comedically small head and large body in the modern age. But all of these, most of these pelycosaurs would then evolve into the next group. Let's just first look at the size of Dimetrodon. Yeah, it was over 4 meters long. You would not want to run into one of them. Yeah, Dimetrodon was sort of the first reptilian land alpha predator, which is quite cool to think. It's bigger than a lion, isn't it? They're incredibly large. But they don't expect they could run super fast because of the way their legs are splayed. They haven't really got the legs under the body yet, like most of the legs of synapsids do. Talking of legs under the body, here are the dinocephalids. So this is the next evolution of the synapsids in the Permian, and these filled out all of the niches. They were the herbivores, they were the omnivores, or the large animal niches. They were the herbivores, omnivores, and carnivores. So yes, they were mid-Permian. They went extinct towards the end of the mid-Permian and towards the end of the Permian in general. A few stragglers held on from the dinocephalids. It's interesting that they expect that the reason they went extinct was disease rather than climate change. I'm not entirely sure why that is, but most of the things they expect, the reason for going extinct at the end of the Permian was the climate change. But apparently these ones were disease, which is very interesting. I'm not entirely sure why. Do more research into that if you want. So yeah, these replaced the pelycosaurs. They were the first group to have these the erect limbs, which we often see today, obviously, in modern mammals. But so back in the day, these are the first things to start having erect limbs. Once again, we're finding one of the first examples of something which is so cool for the Permian, so cool for the period. and they had these interlocking incisors, which is what differentiates them from the synapsids. So notable species, as there is in every section, are moschops, which is possibly one of the other most well-known species from the Permian. I think lots of people know what moschops is, or at least I did since I was very small. So moschops is a large herbivore, as you see there in the top right. That's the moschops. Pinocephalus, which are the largest dinocephalids in the bottom left there. They reached about 5.5 meters, and they had these hardened skulls for headbutting in a manner similar to modern goats and rams. And the dinosaurs had pachycephalosaurids, things like Pachycephalosaurus and Stygimoloch. And there were some more intriguing branches of dinocephalids, such as Asteminosuchus there on the right, which had these sort of crazy-looking head protrusions that make it sort of similar to modern-day boars and things like that, hippos, that sort of thing. And Anteosaurus, which is, you may remember from the start, there was the picture of the Catulorhynchus species, and from that side, and there was another creature with a massive head, which is the Anteosaurus. They had a comically large front of their body and a really small rear end of their body. So they were presumably designed for like a leap from the front rather than extended running. But yeah, they were also pretty large, another 5-meter predators. So we start to see these large land predators, which we hadn't really seen before this period. In the Carboniferous, there wasn't really it was swamp, so there couldn't really be these sort of large land predators. And before then, the colonization of the land hadn't really happened because plants weren't really there. So now we're gonna move on to the therapsids, which are the final form of synapsids in the Permian. And we're going to kick things off with what the alpha predators became. The alpha predators became, by the end of the Permian, there were these things called gorgonopsids. Now, these are incredible looking creatures. They look like massive dogs with huge sharp teeth. They've just got I think, personally, my personal opinion is they have the coolest body plan of any prehistoric animal, with these huge heads and sort of dog-like bodies. They would reach pretty large sizes. We've got evidence of them reaching 3.5 meters, which obviously isn't as big as the biggest anteosaurs from the last period, but they made up for it with the fact that these ones could actually run long distances. They had this parasagittal gait, which is what modern big cats and canines have, so that they can run long distances and short distances at great speed. So yeah, they were likely to hunt like modern big cats with ambush followed by a chase, maybe in groups. And they're probably one of the most studied groups of Permian animal. It's just the fact they had a pineal eye as well, which is sort of crazy to think that the alpha predators had a pineal eye. This is if we had modern gorgonopsids instead of big cats and big dogs, I'd be a very happy man. And so yeah, we'll cover some notable species. A Smilosaurus, which is intriguing because it's called Smile. I believe the picture in the top right is a Smilosaurus. And Inostransevia, I can never get that one right. Inostransevia, which was the largest gorgonopsid, and the other picture of Inostransevia. And by this time, they expected, scientists have theorized that the synapsids had begun to develop hair. So like the gorgonopsid in the top middle, the one, well, that's the only one in the slide. They expected they'd begun to grow hair in a manner similar to modern synapsids like mammals. That video at the bottom there is a tribute to gorgonopsids, which we can watch at the end of there. Now, the most diverse group of synapsids by the end of the Permian were the Decynodonts. Now, Decynodonts were small to large therapsids from the mid to late Permian. And these are one of the only groups that survived the mass extinction, but unfortunately they died out by the end of the Triassic. Their name means two-dog tooth. As you can see, they've got these sort of boar-like tusks. And they were incredibly diverse, as I said. They've got 70 genera, which in comparison to other prehistoric groups is insane number of or prehistoric vertebrate groups, I should say, is insane in the variation. And knowing the way paleontology works, we haven't got anywhere near the number of actual genera that there were. So you can imagine how variable these were. Notable species are Dictodon. Dictodon and Lystrosaurus are very important in terms of the discovery of the movement of tectonic plates. So they found skeletons of Dictodon and Lystrosaurus on multiple continents, which indicated that these continents were once together, as these species were the same. That's just a fun fact. Lystrosaurus, there's an interesting fact about them in the Triassic in the extinction section, and you can see their size comparison to a person there. So they were sort of like the middle ground. They were sort of like the deer, but albeit slower and more badger-like in terms of their gait of the late Permian, early Triassic. And just I had to add it in here that there was a Triassic one, which is called Lysovisia. It's named. It sounds. You can probably tell it sounds very Polish. That's because it was found in Poland. Lysovisia, which was a Triassic branch of the Dicynodonts, and it reached the size of an elephant, as you can see there in that picture in the top right. A huge creature, which is crazy to think that there was something that big that looked like that. Particularly back in the day of the dinosaurs. That was in the first period of the dinosaurs. Now there were also the other important thing we have to know about Dicynodonts is that, particularly for the theoretical section, is that this was the first ever time that the opposable thumb had been evolved. So there was a species of Dicynodont known as Siminia, which has been discovered to be tree-dwelling, and they had opposable thumbs. The skeletons we have found of them had opposable thumbs. And it's sort of cool to think that there were these sort of likely furry, due to the fact that most of the synapsids by this point had probably gained fur, unlike most of these pictures, which aren't really helping. But what can you do? Paleo artists like to draw things weirdly. But yeah, so effectively there was a small monkey type thing in the late Permian, but unfortunately Siminia went extinct in the mass extinction, so we never know what they could have evolved into. But yeah, so that's the Dicynodonts. They were the most widespread group, and the Cynodonts are important for us because you and I, all of you people here listening, you and I are Cynodonts. These are the first mammals. They appeared in the late Permian. They sort of filled in a small mammal niche at the end of the after the extinction. They managed to survive it, and they filled in the niche after in the dinosaur period. They usually look like rats, and they are the evolutionary root of all mammals. Davinia and Jurassognathus are just named examples of what they were. But yeah, the Cynodonts we are Cynodonts, so I could have included an example species of Cynodont humans, but we're not from the Permian, so it wouldn't have been good practice. So yeah, that is pretty much covered that's what life was like in the Permian. Those are all of the main groups in the Permian. That's what happened there, how life changed, and so this is just to sort of look at what the ecosystem would have looked like in the late Permian. And in Siminia, there are no Siminias not in this picture. So all of these sort of cool little variations. You can see Davinia there in the bottom left, the little Cynodont. You can see Dicynodonts. You can see the Pariasaurs, which had survived, the Sauropsids, and the Gorgonopsids, the Stransevia. In Ostransevia, I will say it right once. Yes, so that's what life looked like on land. But first, before we look at the extinction, we're going to have a quick look under the sea. Dun, 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 under the sea. Dun, 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 dun. Everything's better down where it's wetter, under the sea. We're just going to take a quick look at it. We're going to look at invertebrates. We're going to look at the ammonites, the trilobites, and a little bit of the eurypterids, not very much though. And then we're going to look at the vertebrates. We'll look at the bony and cartilaginous fish. We're going to look at the marine life to honour it because it was where most of the extinction happened in the mass extinction. So invertebrate-wise, there were ammonites. There were a lot of ammonites at the time. There were lots of trilobites. Well, there were significantly less trilobites and significantly less eurypterids. Most of the life in the seas was invertebrate-related. However, it wouldn't be for long. So this is sort of like the last period of lots of invertebrates in the seas, taking up like the main niches. So trilobites, this was in fact the last period where we would ever see trilobites, sadly, which is probably a shape that you all know well due to their frequency in fossils, along with ammonites. But yeah, so the Eurypterids, I should add, are giant sea scorpions, which had dominated the food chains in the earlier periods in the Devonian, Silurian, and Carboniferous. If you look here at this picture, you can see that only 1, 2, 3 groups of Eurypterids survived into the Permian, and none of them made it to the end that we know of. We think some of them might have made it to the very end, but none of them made it out. And trilobites were all made extinct by the Permian mass extinction as well. So this is sort of like the last great age of invertebrates, sadly enough. But no, bony fish, which had just sort of began to really prosper. They came into their own really in the late Silurian, early Devonian. They were expanding a little bit. We see modern looking fish like the Acrolepis there in the center middle and the bottom right. They're beginning to look like modern fish. And coelacanths appeared for the first time in this period, which is cool because we can see them in the modern age. It's pretty cool to have something from that sort of time still seen today. They usually had bony faces. The fish back then had bony faces. You may recognize there's a species of fish called the Dunkleosteus, which is from a few periods back. So most of these fish were related to that. And there were a lot of lungfish. That's another thing that's important to note. Lungfish were much more prominent back here, but they also took the hit of the mass extinction. Now we've only got a few modern lungfish. But cartilaginous fish-wise, wow, Permian had it going good. If you're a shark fan, like I know our president Seb is, and I am, you would have been happy to be swimming out there in the Permian. Well, you wouldn't be happy to be swimming in them, but you'd be happy to be studying the Permian seas. There's a lot of variation in what the sharks look like, but they generally didn't look like modern sharks. So the scaly-faced fish like the Dunkleosteus had just finished. They'd finished their time, and there was a niche left as sort of the alpha predator in the oceans. So the sharks very much filled it in with some very intriguing body shapes. So if we look there at the top left, you can see the Orthocanthus that could reach 3 meters long, and it was sort of like an eel shark with a massive spine on its back. And rather than having like the shark dorsal fin, they've got this sort of lobe. So they look almost eel-like, and that's the way they hunted. And Xenocanthus, seen in the bottom right there, with a sort of smaller version of that shark, or the cartilaginous fish more when they're that size. But the most intriguing shark of that period was the Helicoprion. You can see the Helicoprion in the. I will call it Helicoprion and Helicoprion. I'll call it different things. Just ignore that. Which is the shark with a saw for a jaw. You can see in the top right there the size of them, and you can see a picture of what they sort of look like with their mouths. And we'll talk more about that. So on the next slide, there's some stuff related to the Helicoprion. And the Hybodus shark, which is seen in the bottom center there with a size comparison to the human. So that group of sharks did really well after the mass extinction and filled in the sort of medium scavenger niche for most of the time of the dinosaurs. So you would see a lot more of that if we looked at sort of Triassic, Jurassic, and Cretaceous seas. So we'll look at Helicoprion because Helicoprion is an intriguing one for scientists. Is that they found the sort of curly teeth, the tooth saw, and they did not have a clue where it was meant to be. A lot of them thought, so you can see early on, they thought it would be like a massive curving tooth rotatory on the lower jaw that would sort of lie out like a massive hook. But then they quickly realized that would be not very helpful for swimming. You get it caught on things. And so they as it's called, an extended lash there. And so yeah, eventually they realised that it would be more likely to be wrapped up into the mouth. And the reason that there were so many teeth on the rotation is that in the manner of modern day sharks, the teeth were constantly being lost, so new ones were produced, and they were rolled along the saw almost in the way like a chainsaw is, but instead of the chainsaw going back around, teeth were just lost when they got to the end, just because of the way they ate, the sort of way they ate. And it's quite incredible to think that there was something that was that big with a jaw like that back then. And the reason the jaw looked like that is because they primarily fed on the invertebrates, which was so common in the sea then. So they didn't really need to have that sort of the classic modern shark bite. Instead, they could just slice through things with that pretty useful, just like singular slice for catching squid and stuff like that. And marine reptiles. So now we're back to the mesosaurs. In the mid to late Permian, the mesosaurs were like, you know what, I've had it with the land, I'm going back to the water. And mesosaurs, they are the root of all of the huge variation in marine reptiles that we see in the era of the dinosaurs. So mesosaurs, they paved the way for the ichthyosaurs, the elasmosaurids, the plesiosaurs, the pliosaurs, and the mosasaurs. All of that crazy variation that happened in later periods, it came from them. Came from them making that jump. Yeah, crazy little creature decided to make the leap, and it works out. Good for the mesosaurs. Right, so that's what was on land and what was in the air. A couple of things. What was in the seas, and now we're just going to talk about them all dying. We know what they are. Now we're just going to talk about them dying. What a fun thing to do. So yeah, the most important thing that happened in the Permian in most people's eyes is the Great Dying, which happened at the end, which saw nearly all of life on Earth just wiped out. So what was it? The Permian Triassic mass extinction. The percentages of what was killed off are 81% of marine life and 70% of terrestrial life. It just became extinct, and those numbers are extremely high. Even if you compare it to the modern mass extinction that would be occurring, they don't come close to those numbers. This was sort of like everything on Earth dying out. Yes, so marine systems had a tougher time of it, and it signaled the end of the Permian and also the end of the Paleozoic, a larger period where the invertebrates were primarily the rulers, and the beginning of the rise of the vertebrates. There were three sort of pulses of extinction that occurred during the mass extinction, and there's lots of theories about why this occurred, but the most commonly brought up one is that there was a huge increase in volcanism, a sort of huge, long-lasting volcanic eruption in a place called the Siberian Traps. So if you see, there's a picture there on the top right where that is, and all of that land that's covered under those lines there was created during this Permian mass extinction. So there was effectively there was the creation of such a large landmass that the volcanism required to create that land was significant enough to result in such massive differentials in climate that the animals on Earth just couldn't hack it or died out. So it was the rapid climate change that primarily killed things, which is why people link it to the modern mass extinction that's going on, is that the root of it is climate change. But the climate change then was much more significant, I'd like to point out, than the one that's going on right now. So I think the modern Great Dying can't really be compared to the sort of scale of this one, unless it gets worse, which it probably will do. Yeah, I probably jinxed it there, haven't I? So it took life 30 million years to recover on the land, which is quite a lot of time. It was quite a significant amount of time. In the seas, it only took about 10 million, but that's because seas are generally better at bouncing back from things like that. And it just saw the end of so much. We'll look at what it saw the end of here in marine life. You can see here on the right, there's a very useful graphic, which is on Wikipedia if you want to look more into the mass extinction. And it just tells you the percentage of genre in the groups that went extinct, and the numbers there are just ridiculous. 100% of trilobites, 100% of eurypterids, which we've already seen, And there's just other things like if we look at crinoids, we still see some of today. 98%, 79% of bryozoans, and 96% of brachiopods. It's just ridiculous, the number. Even 59% of bivalves and 98% of gastropods. Imagine if imagine the number of gastropods we have today is pretty significant. If we saw all of them dying out, it would be pretty devastating. But yeah, some also to add on to those, that's only inverts on the right, mostly invertebrates. There's one chordate group. There were so significant losses in sharks, those sort of things. So the helicoprions were lost, which did lead to the bony fish taking over a lot of the roles that the sharks had in the seas. Yeah, and it saw the change of the biomass being mostly invertebrate to mostly vertebrate in terms of the sort of numbers, the percentages. And you can see there in the bottom center, it's the warming was obviously focused around the equator, which meant that the species that were in the equator actually did better because they were more used to the change in temperature. But because there was such a significant change in temperature, everywhere else on Earth suffered as well. Yeah, so it was pretty devastating for everywhere. I'm being honest. I don't know why I'm trying to differentiate. Everywhere on Earth was completely devastated and nowhere did well. Terrestrial life, look at those massive red crosses. They didn't survive. 2/3 of all terrestrial vertebrates died out. It's ridiculous, the numbers. Nearly all of the synapsids, apart from the cynodonts, which we are, thankfully, we managed to survive it, and some dicynodonts, which is where Lystrosaurus comes back up, because Lystrosaurus managed to deal with the mass extinction very well. Likely, due to the picture in the bottom centre there, due to their passion for horsetails, which didn't do too badly with the mass extinction. And they made up nearly 90% of early Triassic biomass on land, which is a crazy number. But the bigger synapsids just completely went. The Gorgonopsids, and then the Sauropsid Pariasaurs were just gone. But an important sauropsid that did manage to hack it was the Dromaeron, seen in the bottom right there. Dromaeron had just begun to walk bipedally, and they are the root of all of the land dinosaurs. So, yes, lucky thing they survived, or else we wouldn't have got dinosaurs. But yeah, so it's not all doom and gloom though. So effectively the world was knocked down to a blank slate, but it led to the dinosaurs filling in their places on the land. The Echinoodonts, obviously, we know they grew to big sizes like Lysobisia, but eventually, even by the end of the Triassic, they were gone too. And all of our relatives remained small and hid away for just waiting our time in the spotlight. But it's not all doom and gloom. The dinosaurs had their turn now. Some sauropsids decided, you know what, I'm going to fly, and they became pterosaurs, filling in the aerial niche, which had started to be filled in a lot more because flying insects were now very much a thing. So that niche had become a predatory aerial niche had become a real thing, which it hadn't been before. And the mesosaurs obviously became the aquatic. Such the huge variation in aquatic reptiles that we saw during the period of the dinosaurs. There's an interesting one there in the top left picture, is the Tanystropheus, which was a primarily land-based reptile that could also swim, and it just had a huge neck for fishing. So it wasn't all doom and gloom. And the Triassic is a very interesting period, which I would be more than happy to do a talk on as well. But now we're going to have a little think. We're going to have a little think. We now know what happened to the Permian. We know what happened at the end. We know what went extinct. But what if it never happened? What if none of that had happened? What if there was no Siberian traps? What if there was just Siberia, full stop? There was no Siberian traps. There was no destruction. There was no volcanic activity. What could have happened? Well, on land, let's think about it. Let's have a little think about this. Now, this is just me spitballing here. Okay, I've had a think about this. I've had a good long think about this. So the large animals that took their primary places would likely have still maintained their roles. So there would have been the synapsid alpha predators. The gorgonopsids would probably have continued to vary and change in the way they looked, probably becoming more mammalian, as they were already beginning to look a little bit more mammalian as time went on. They were growing. They likely became hairy. They were probably looking more and more mammalian as the years were going on. So they probably would have continued to become mammalian. The declinodonts would have continued probably their size rise along with the pariasaurs. I have a feeling though that the pariasaurs towards the end of the Permian, they were beginning to die out as well. So that was sort of the last kick they needed, was the mass extinction for them to go extinct. So I have the declinodonts were likely have continued their rise and formed things like Lithivisia anyway, and taken up the role of the large herbivores. So I think eventually, so we have to bear in mind that the time that these animals would have had to evolve is roughly, I should have written it down because I'm working it out now in my head, from 250 to 65. So they've got well over 100 million years to evolve. So they would have had a good amount of time to evolve into a wide variety of things. But it would have been the main things from the end of the Permian just continuing to evolve and change and become different things. But the more interesting one is the fact that we had something that had opposable thumbs that went extinct. And if that had not gone extinct, would it have continued down the path that our ancestors did of becoming more and more complex? Would they have formed complex life? It only took 50 million years for modern humans to evolve from their first opposable thumbed relatives. So, and with Saminia having roughly 150 million years, would a civilization have advanced sort of, I want to say humanoids, but I don't know, Permianoids, Suminioids, would they have formed in their place? It's an interesting question. And it's not, obviously it's not one we can answer, but it's definitely up there for ideas. And obviously temnospondyls, of course, would have continued to fill the role of crocodiles. And during the time of the dinosaurs, and even more recent history, there have been much larger crocodiles than the crocodile-like amphibians that we saw from the temnospondyls. Would they have filled in these giant crocodile niches towards the end of in their time? And in the water and in the air, obviously, the unconventional sharks would likely have continued to change and vary, and form more weird and wonderful shark forms. The mesosaurs, the role of the herbivores and the benthic creatures, they were dying out anyway, the marine herbivores. So it could have been that the mesosaurs would have become herbivorous rather than the predatory ones that were formed instead. And they could have formed things like the picture next to the helicoprion and the picture at the bottom left. They could have formed creatures like that. The picture at the bottom left is a real marine reptile that formed. So they could things like that could have probably formed anyway. Invertebrates were probably still, they were on the decrease, so they probably would have continued to die out. But one that paleo artists have had a lot of fun with recently is the concept of if Weigeltiosaurs, which didn't really do well after the mass extinction, they were gone by the end of by the mid-Triassic at least, or at the max. Would they have filled the aerial niches like birds in the Cretaceous and like pterosaurs in the Triassic and Jurassic? And if they did, it's an interesting question because their body structure was much more similar to that of our Western concept of dragons. So we would maybe have had creatures that looked like dragons in our past if the Weigeltiosaurs had not been knocked out the way they were. So this whole section is just theorizing and just having a think about what could have been. But I think it is a fun thing to think about, and it's an interesting thought. But to the end of the talk, thank you for listening. I hope you've learned something about the Permian. I hope thank you for that very quiet clap, whoever that is. And yeah, if I thought it would just be fun, so I've suggested some of the possible evolutions that could have taken place from some of the late Permian creatures. It'd be quite nice if you could draw some. I know we have some artists with us here, so people that like drawing crazy evolutions of things. But yeah, if you want to, maybe draw like a sort of dragon-like Gygotis or something like that. But yeah, thanks for listening. Any questions, I guess?
Yeah, why did the two skull types diverge? What's the advantage of having a synapsid skull versus a sauropsid one?
Well, I don't think there's like an inherent advantage of it. I think it was just that time synapsids took the initiative, and they were sort. I guess they were the lucky ones then, because the sauropsids were still around. There was no like inherent negative evolutionary flaw from evolving a head shape like that. They were still able to survive, and then they eventually they blossomed into the dinosaurs, didn't they? So I think it was more just like it was an evolution of circumstance.
Yeah.
That they got why they did. There's probably like, oh, they're better at maintaining their body temperature or something like that at that point. But I'm not entirely sure why they took the yeah. Any other questions?
Yeah, where can we share any drawings we do? Because that's kind of right up my thing. I love doing that kind of stuff. And also, thank you for explaining the heliosaur. That's been bugging me for ages. I love that. I love the shark thing. But
the helicoprion,
the saw shark.
Yeah.
I can't remember the name. Yeah, love it really.
Yeah, I guess you could put them in the Ecosoc community chat and also in the Ecosoc community Facebook group.
Or email.
Yeah, or just email them to me. I don't know. I don't. Just if you just send them to Ecosoc, I think we'll do like maybe in about a week we could share some if people draw them over the next week on our Eco, and just say it was as a result of this talk. I'm going to stop recording. I'm going to do that.
Well, you might as well. I've got another question.
Okay.
If the helicopteron, like we were just saying, which way did the teeth fall out of it? Because if you think of like modern sharks, it's kind of like a conveyor belt of teeth.
Yeah.
So
what I was saying is they also had the conveyor belt of teeth, but they were just the conveyor belt went sideways rather than back to front like the sharks do.
Yeah. Okay.
So no, when I'm saying the teeth are falling off, as in the way like a modern day great white, one of its teeth. Taking place. The helicoprion would have had to have sat there with a hole in its teeth for a while, but then eventually the
new thing rolls around.
The new one would have rolled around. Yeah. It's just a different way of doing it.
Yeah.
But I mean, it worked because they were primarily hunting inverts, weren't they? Rather than
So would it have had teeth on the top jaw?
I don't think they did have teeth on the top jaw.
So it's
it's just the saw.
The mouth is just a big scissor.
Yeah, should we go to the
just to chop mollusks in half?
Yeah, I really like the picture of it going for the squid. It's he's going for it. He do be going for it.
Yeah, because of course you just snip that in half.
Yeah, and then it's yours. It's all there. I don't know why they need to evolve to be 7.5 meters long. See the evolutionary advantage.
Cool.
Yeah, big things get bigger. Well, it didn't end up well enough for them, did it? Because they got extincted and got replaced by blimmin' ichthyosaurs, which are the worst ever.
Yeah.
Worst example of aquatic alpha predators.
What was the shark that got discovered a little while back? Was that from the Permian?
What do you mean the shark that got discovered?
The one that kind of looked like a plane. I don't remember. Like it came out.
Oh yeah, the recent shark. I'm not sure. That might have been from the Permian.
Do you know what it was called?
Plane shark. No, that's a plane with a shark drawn on it. Glider shark. What about that? Because that's why they. No, that's also.
No, it's Fortnite.
Yeah. Species. The eagle shark. Here we go.
Ooh.
No, 93 million years ago. No, that's not Permian. Looks cool though. Yeah, we love sharks here at Ecosoc. George, have you got any questions? There was some crocodile related stuff in there. I know you like crocodiles.
Oh,
George,
man, I don't
George, why don't you draw a Weigeltosaur evolution? Huh? What about
I
a
don't know where any
primitive dragon?
paper. No, I might draw something.
The
Enjoy
amphibian version of snakes look way cuter than the actual reptile version of snakes. I'm just
Yeah.
like,
Yeah, enjoy
to
the
throw that in there. They look like the smiling. It's better.
Unfortunately, they were gone by mid-Permian, so
No.
Is
Yeah.
this the Eagle?
Think
They
of
were
what
very
it could
happy
have
then.
been.
unfortunately things just got too dry for the amphibians. They didn't like it, and unless they were 9 meters long, apparently. I don't know what Bryosuchus was doing, but it was doing something right. If it was
Pretty mad. I
still-
didn't realize they got so big.
Everything got really big.
Yeah.
I think was it because of the oxygen that stuff got so big, or was that just for insects?
that's just the inverts, yeah. Bryosuchus wasn't big at the start of the Permian. They only got that big by the end. I'm just trying to find it. Where is it? Yeah. But I guess the Bryosuchus only got that big at the end because that was a niche that wasn't there before.
Yeah.
Well, it was there, but I don't know if you know this. Back in the Ordovician, I think. Yeah. Oh no, Silurian. Sorry. That role of sort of like the amphibious large predator, or the crocodile, was filled by a lungfish, a giant lungfish.
Oh wow.
Which is pretty cool. Yeah, that's just a little bit of extra info. But yeah, this period is sort of the first period where you can liken the niches to the modern niches. The ones
Yeah.
beforehand, the world just was so different. This is where it was starting to look a bit more modern, which is why I chose it. And obviously the mass extinctions are quite interesting as well.
Yeah. So the mass extinction was just caused by all the tectonic activity in the Siberia, or where
Yeah,
Siberia is now.
Yeah, creating the climate change, which
Yeah.
led to the extinctions.
Where was
some people
Siberia
think
in Pangaea? Was it?
It was at
like
the
on
top
the edge?
still.
Yeah.
It was at the top. We go back to the. You can still see my stream, can't you?
Yeah.
Yeah.
I just forget which way round it was.
It was up here. Yeah. So it was towards the North Pole.
Yeah.
How quickly?
It's a strange image of a globe there.
Yeah, but it is Yeah. That's the South Pole, so the North Pole's up there.
Yeah. Okay.
Oh, I see. Yeah.
I guess that is sort of close to the. That's probably the equator, isn't it? So yeah, it's probably mid-equator, but it's in the northern hemisphere, whatever.
Yeah.
Yeah. Any more questions? I feel like that's sort of covered it all. It's an interesting period of history, and I'm glad I've got to talk about it.
Yeah.
Yeah.
Yeah, thank you. That was pretty cool.
Thank you all for coming.